First, some vocabulary. A sequence, by definition, is an ordered list of numbers. Here's an example of a sequence. 5, 8, 11, 14. It's a list of numbers. It's called a sequence. Term. It's one of the numbers in the list. So each of those numbers is called a term. As the list is an ordered list, order matters. Each term has its rightful place in the list, denoted by a subscript. So a sequence could be represented by T sub 1, T sub 2, T sub 3, and so on. In the above example, T sub 1 equals 5, T sub 2 equals 8, T sub 3 equals 11. So I've introduced you to a new style of notation. It's called a subscript. One of mathematicians' favorite hobbies is to make up notations. The above is an example of a discrete function, f of n. Discrete functions are different from the other functions, f of x, in that the domain of f of n is the natural numbers, and the natural numbers are 1, 2, 3, and so on. It's like they're discrete functions in that you can't have 3.5 students on a bus. You have 1 or 2 or 3 or 4. That's what a discrete function means. And in this case, f of 1 equals 5, f of 2 equals 8, f of 3 equals 11, and so on. So you'll see both styles of notation in textbooks and in discussions. Sometimes it'll be f of 1 equals 5, sometimes it'll be t sub 1 equals 5. Arithmetic sequences. Now here's the word arithmetic. But by the context, we know that in this context it's arithmetic, and it has a particular meaning. Consider the sequence, 5, 8, 11, 14. In each instance, when we subtract backwards, when we subtract the previous term, we always get 3, i.e., 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is 3. Sequences that result in the same number, regardless of where you subtract backwards, are called arithmetic sequences. So this is an arithmetic sequence. The number that you get when you subtract backwards has a name. It's called the constant difference. Constant because it's always the same. Difference because it's the result of subtraction. And we give it a letter. It's the letter D. D equals 3 in the above example. Another arithmetic sequence for you, 5, 1, minus 3, minus 7. D equals minus 4 in this case because when you subtract backwards, when we look at this and say 1 minus 5 equals minus 3 minus 1 equals negative 7, subtract negative 3, you're always getting negative 4 when you do this. 1 minus 5 is negative 4, and so on. Constant difference is the result of subtracting backwards, and that's always negative 4 in this case. General formula for an arithmetic sequence. We denote the first term of a sequence with the letter A, kind of like the first letter in the alphabet, and the common difference with the letter D. Using that, we could say that T sub 1 is A, T sub 2 will be A plus D, because every time you move to the next term, you simply add D. So T sub 3 will be A plus 1D plus another D. So that'll be A plus 2D. And T sub 4 will be A plus 2D plus another D. So that'll be A plus 3D, and so on. T sub 5, it will be A plus 4D. Now to find the general case, we make an observation. Let's observe here. This number 4 is 1 less than this number here, which is 5. This number 3 is 1 less than that number 4. This number 1 is 1 less than that number 2. So the number that goes here is always 1 less than the number that goes here. So here's our general formula. T sub n equals a plus n minus 1 times d. And there's your first formula you need to write down, the general formula of an arithmetic sequence. Let's do some examples. Example: given a sequence, state the nth term and the 17th term. Here it is, the sequence we've been looking at. Here's the solution. Express the sequence using the general formula. When you're given a formula, it's a good idea to write it down when you first use it. There it is, T sub n equals a plus n minus 1 times d. And we know that a is 5, because that's the first number in the sequence. And we know that d is the result of subtracting backwards, so that we know that d is 3, and simply plug them in. Notice I put brackets around 3 here to denote multiplication as opposed to addition or subtraction. And since this is grade 11 math, I'm going to take for granted that you can get from this line to this line. And if necessary, do it on a piece of paper. Now for the 17th term, take the formula, which we just figured out for this sequence, T sub n equals 3n plus 2, and sub in 17. So T sub 17 is 53. I always laugh when students ask for T sub 17, roll out 17 terms here, and go to the 17th one and say, T sub 17 is 53. Okay, great. But suppose somebody asked for T sub 412. Moving on, let's go again. Given a sequence, state the nth term and the 17th term. There's a sequence. Here's a solution. Express it using the general formula. First, write the formula down. Next, a is 1, because that's the first term. D is the result of subtracting backwards. That'll be minus 3 subtract 1, which is minus 4. Plug them in. Make sure you use brackets when you do so, right here, to denote multiplication. And I'm going to take for granted that you can get here, because this is grade 11. Now the 17th term, simply plug in 17 for n. There's the general formula for the sequence. Plug in 17, do the math. T sub 17 is minus 63. Another style example, which is very common, is as follows. Find the number of terms in a sequence. Here's 1, 2, 10, 18, and there's a whole bunch of missing terms, and it goes up to 266. The solution? Use the formula and find n. Well, there's the formula, and we know that a is 2, and we know that if you subtract backwards, 10 minus 2 is 8, so d is 8. Now this number on the end is T sub n, and this is the part that people miss. This is T sub n. It's not 266 sub n, it's not T sub 266, that is T sub n. Plug them all in to the formula, do the math and solve for n. So the right side expands out to this, and then solving for n we get add 6 and divide by 8, and finally n equals 34, and there's 34 terms in the sequence. One last example. Find the formula for an arithmetic sequence given 2 terms. T sub 10 equals 8, T sub 22 equals negative 52. What's the formula for the sequence? Solution? Sub the given terms into the formula twice. That's going to yield 2 equations in 2 unknowns. So, there's our general formula. Now here's the thing. This is code. It's saying that when n is 10, the term is 8. In other words, when this n is 10, this term is 8. So it will be 8 equals a plus 9d, because it's 10 minus 1. So this will become 8 equals a plus 9d. Next, again, this is code. And it's saying that when n is 22, the term is negative 52. So using this formula, this term becomes negative 52 when this n is 22. So 22 minus 1 is 21. So this line will become negative 52 equals a plus 21 times d, like that. Now it's grade 11 math, so you know about solving by elimination. So when we examine our two equations, we see that there's a and there's a. And when the signs are the same, you subtract. So we'll draw a line and subtract. Subtracting carefully, 8 subtract negative really means add. So 8 subtract negative 52 is 60. And 9d minus 21d is negative 12d. Solving here, we get d equals minus 5. Then take that and sub it back where you see this asterisk. So I'll take d equals minus 5 and plug it into that line. It will look like that when you plug in using brackets like you should. Do a little bit of math, and we know what a is. A is 53. Now we know what d is, and we know what a is. Now we can plug them, both of them, into this general formula. So let's do that. There's the general formula. Plug them in. And this leads to, and I'm taking for granted that it leads to it because you're going to do it on a rough sheet and find out that yes, t sub n equals 58 minus 5n. I'm Ziggleby at Beeshtuke, and thanks for watching. If you liked it, leave a like. If you like the content, please subscribe. Check back daily for updates and new videos, and I'll see you soon.